Hi, so this is a web parsing tutorial using BeautifulSoup and RoboBrowser in Python. And the reason I wanted to make this video is because I've seen a lot of tutorials and they just use perfect HTML and they just don't really talk you through it much. So I just want to make a quick one, and I will assume that you've already had a look at the BeautifulSoup documentation. And I won't go too much into RoboBrowser. We're just going to be using the basic function to open and to parse. We will also be using pathlib, which is my favorite way of working with paths in any operating system. I'm on Windows, and we'll be using this in order to work with our CSV file. And so our goal in this tutorial is, on this website, which is just market data from a video game, is to get some of this data into a spreadsheet. And then theoretically, you could run it on a server every 5 minutes or something and make informed decisions based on that. So the first step is we're just going to go ahead and just import our packages. So we just need to import RoboBrowser and BeautifulSoup. We're going to go ahead and just start a browser, and we're going to go ahead and open the URL that we will be using. This is all going to be in the description below and on my website. So once we've initiated a browser and opened the URL, we actually need to parse it. So we will try to use the default RoboBrowser parser instead of the BeautifulSoup one. And if that doesn't work, then we're going to have to use the BeautifulSoup parser. And we're just going to go ahead and print the soup. And let's see if that actually worked. Okay, so it has worked, and we do have the HTML. So instead of trying to read the HTML from here, I'm actually going to go ahead and just open it and over here, just to have a better look at what the data is that we want. Okay, so we can immediately see that the data is nicely organized here. And what we're looking for when we look for this HTML is a way to select the data that we want. So sadly, there's no clear way to select the values that we want. So this is the volume and this is the price. Those are the two we're going to focus on, volume and price for now, and maybe station. So I don't see a clear way to select this. So what we could try to select this here because as we can see, we have a unique href. So we can use BeautifulSoup to select this using the find all. So you could write something, this is just an example. You could write something like soup.findAll href equals true. And then you could use that to select everything that has an a attribute and an href attribute. We could also try class order history, and then we could try to use next sibling. But I don't find next siblings easier than just selecting TDs. So we're just going to start by trying to select every TD in the page. So we're just going to go ahead and do, we're just going to do tag equals soup.findAll TD. That's it. And then we're going to just print the tags. And hopefully we'll have all the TDs, including the data that we need. Okay, so what soup.findAll does is it returns basically a soup, although it's not a soup. It returns a list, although it's not class list, it's some BeautifulSoup object. But we can treat it as a list in this case. So actually what I want is to look at the strings, because all the data that we need is inside the strings. So this would be a bit different if it was inside the attributes. So for example, if we were looking for the value of the href, that would be a bit different. We would need to use something like this maybe to get it out. But since we're just looking for the data within, in each case, for example, the data within the TDs, we can just do tag.string. So for example, you could select the first tag and do .string, and it would return this value, 524 something. So let's just do that. Okay, yeah, see, we've returned this. So what we can do is we can just loop through the strings. So we can do for element in tag, print element.string. And this should print all the elements as strings. And it has. So now we just need to figure out the order, and we can just manually select it. So first we have the order ID, which we want. Then we have the date, which I personally don't care about right now. Then we have the volume. So we've got 0, 2, and then 4, because the price. So it seems to be just skipping in 2. So what we can do is we can wrap this in an enumerate. That way we can work with the indexes easily. So I hope you know what enumerate does. If you don't, you can go look it up. It's pretty simple. Then we can just do tag idx dot string, which would print all the tags. And then we can do tag idx plus 2, which should return the volume. Then we can do print tag idx plus 4, which should return the price. And print tag idx plus 6, I think. I'm going to have another look. Let's see. So 0, 1, 2, 3, 4, 5, 6. Okay, so we're getting the ID, the volume, the price, and the station. Okay, so that should theoretically work. Oh, but I think we will have, okay, yeah. Okay, so the danger with using this method is that it's not really considered Pythonic, because when you're doing index plus 6, you obviously run the risk, or even most of the time guaranteed risk, of getting an index error, which is what I think we probably got, because, okay, yeah, obviously we go out of the range. So there are ways to solve that. In this case, we're not going to need this data at the bottom. We're mainly focused on the first data, especially since we're more interested in the buy orders. I think the second half is sell orders. The second half is mainly buy orders. So let's just see where it failed. So did we get all the data? We actually did. We got all the data before it went out of bounds. So that's not bad anyway. So what we can just do is we can just wrap this in a try except. And we can just do continue. Let's see if that gets rid of the error. Yeah. Okay, and let's just look at the bottom of our data. So I don't want to be capturing the regions. Why are we capturing the regions? Just have a look. Oh, right, that I've just done a silly. It's because we're looping over each index. So what we need to do is loop over only the indexes that contain the order IDs. So that was quite dumb of me. Okay, so what we need to do first is somehow get a list of these order IDs, which I assume are unique. So we're going to do that in a separate way. Oh, so actually we're going to get to do what I said earlier. Order tag, we're going to call it. And what we're going to do is we're going to look for, we're going to look for the order IDs. Let's see. Okay, so there's a lot of tags of hrefs. Let's just make sure the order IDs are here. They are here. Okay, so we're just going to select anything with history. Okay, so for element in order tag, if history in element, print elements. So this should only print elements that have history within them, theoretically. Oh, it didn't print anything. Right. Right, let's think about how we can do this again. I see, because we're trying to select what's inside the href. So how do you do that again? You do print L href, I think. Let's see if that does anything. Yes, it does. Okay. Okay. So for if history in L href, because we're looking for history which is inside the hrefs, print element. Okay. Okay, yeah. So we can even just do print element.string, and then we'll have all the order IDs. Yeah, okay. So we're going to go ahead and separate this. Getting order IDs, and then we'll do this actual parsing. And we're just going to add all the order IDs to a list. So we're going to make a new list. Because what we want is we want the order IDs so that we don't have to loop through everything. So I'm not 100% sure where I'm going with this, but it feels like the right thing to do to have the unique order IDs. It's always better to have more information that we don't need later. And it doesn't take long to get it. It's just a few minutes wasted, worst case scenario. So here we're just going to do order ID list.append element.string, right? Or is that wrong? I think that's correct. Okay, and then I don't think these are unique, so we're just going to turn them into a set and then back into a list, just to make sure we're only dealing with uniques, because I also want that. And we're going to assign that to itself. Then we're just going to print, just to make sure that we still have the data. Okay, so as we can see, we have a nice list of strings, which are the order numbers, and there don't seem to be too many of them. So that's perfect. I'm not sure what I want to do with this, but we'll see. So let's rethink this approach here a little bit. How can we do this? So what we could do, so let's just go back to printing l.string. Let's just go back to this and see what we have again. So what we could do is we could say if, yeah. Okay, so what we're trying to do is we're trying to find a way to extract this information. Before I wrote a loop which just loops over everything, so that's not very helpful, is it? So what we can do is we can say if element is inside this order ID list. So if element is in order ID list, that's what I called it, then print element. Actually, we're gonna go back to IDX, tag IDX, print. We're gonna do tag IDX +2, and we're gonna do tag IDX +4. And print tag IDX +6. I think that's correct. So let's see if this only gets us the data that we want. No, it doesn't. Why? Oh, is it l.string that we have to do? Yeah. Okay, so I forgot the string. So let's just copy this. Okay, so that worked. So we have the data that we want: volume, ID, volume, price, region, location, etc. It doesn't seem to have taken any data, and we have fixed our issue. We don't even have an index out of bounds, so we don't have to use a try except. So that's perfect. Now we have the data that we want, and we need to think about how we're going to store this in Excel. So my favorite way is dictwriter, because dictionaries are quite useful. So what I like to do is put all this inside a dictionary. So we're going to make an empty dictionary. So we're going to say, I don't know, information dictionary. I'm not very good at my names today. Or let's make this shorter. CSV, export dict. Okay. So what we're going to do is we're going to say order ID is equal to tag idx.string, right? Oops. Actually, no. Let's first turn these into. Let's first get the variables, because I have a feeling that it might be better to turn them into integers. Might help us deal with this, and we're going to need to do a little bit of replacing, because as we can see, we've got commas, we've got dashes, we've got full stops. We don't want most of this. So order ID, we're just going to have it as an integer. Then we have the volume. So volume, we just wanted the volume left, actually. So what we can do is do tag idx, idx, +2.string. And we're going to go ahead and do .split on here. We're going to go ahead and select the first one. And then we're going to do .replace to get rid of the commas. And that should be it. And then we can turn that into an integer. So that should theoretically work, right? And we'll do something similar for price, but it's a little bit different, so let's not copy paste, so we can make sure to do it correctly. So for price, we don't need to split, but we do need to replace, let's replace commas as well, because I don't know how high the prices go. And we need to replace full stops. Okay, So that should work for price. And then we've got region, which is just as it is. We don't need to change it. It's fine as a string. Oh. Okay, so now we can just do order ID equals to order ID, export dict volume is equal to volume, export dict price equals to price. See, it becomes a lot more readable if we do it this way. Export dict location equals to, oh, I named it region, whatever. Okay, so we can delete these print statements. And this should theoretically work, right? So what we can do is just print our export dict at the end, just to make sure that worked. Okay, so we just get the last export dict, and that seems to have worked. So now we need to think about one thing. The one issue I have is the fact that sell and buy orders are on the same page. So one thing we could do in order to separate them is just look at the price. When the price, because obviously as we go down the sell orders, the price is increasing, right? And then it suddenly decreases. So what we can do is, if the price decreases, we don't want this information anymore. I think that might be our best thing to do, which is great because we actually have the price here. Okay, so what we can do is do price previous is equal to 0. How are you going to, what's the best way to do this? Let me think. Okay, we can do if. Okay, so first, okay, let's leave that. We're going to do it in a second. First, we need to be able to write this data, right? So let's go, we're going to need to use pathlib. Let's first actually just go ahead and go to dict writer. Here it is. Okay, so we're just going to go ahead and copy this. We're going to import CSV. And we're going to do from pathlib import path as well, because I have a feeling we're going to need it. So let's just build that, make sure it still works. It does. Okay, then we're going to go ahead and just copy this. Okay. Okay, so a few things. For field names, we're going to go ahead and use our export dicts. Field names equals to, we're going to use our keys from the export dictionary. And we're just going to write row, we're going to write the dictionary, which is called export dict. Okay, so now one of the issues we have is that we don't want to write the header each time because we're doing this in a loop. Also, we don't want to overwrite. So we're going to name this, I don't know, of titanium data, okay? So we want to have some kind of logic to only write the header the first time. So sadly, dictWriter doesn't have such a simple logic. So what we can do is we can check whether the file exists or not, and if it doesn't exist, then we write it. So that's part of pathlib, right? So to do this, we're going to need a path. So let's do this outside the loop. Let's do file location is equal to path, and then we'll just take this as a string. And we need to change these. Here we go. And we're going to do, what was the name of our file again? Titaniumdata.csv. Okay. So what we can then do is check if this file exists. So we can do, let me think. If file location dot is file, is true, write head equals false, right? Else, write head equals true. I think that's correct. So then we can do in here, if right head equals true, oops, right head. Oh, is it? Oops. Is that correct? I think it is. If it's a file, don't write head. If it is, write head. Yeah, okay, that seems correct. Okay, so let's just go ahead and run this and see what happens. Oh, invalid syntax. Yeah, so I thought it was too. Why is it giving me an error? Oh dear. Sorry. Okay. Yay, 13 kilobit. That's a lot of data. I'm guessing we've failed and we've written it every time. Oh no, we haven't. Okay, so that worked perfectly. Okay, so that's pretty good. Okay, so I already spot a mistake. We removed the dot from the price, but we forgot to divide by 100. That's why it's useful to have it as an integer. So there you go, we fixed that. And also our issue is that we, as the prices increase, we also have the buy orders, right? So what we need is, okay, so we could cheat and say if it's not a string, because it's the buy orders seem to have like broken regions, seems to be different. But I'm just gonna do what I initially said and do some type of price comparison. Okay, so don't save, and we also want to delete that. So that the file doesn't exist, otherwise we won't write the names. Okay, so let's think. How can we do a comparison? So if we set price to previous, and then we can write, and then we can compare again, right? This doesn't seem right. How can we do this? Give me a second, let me think. Well, we could wrap this entire thing into an if statement, right? So we can do if price previous less or equal to price, do this, right? Would that work? I don't know. I have a feeling this is wrong. Let's see. Nope, we're still at 13 kilobits. I'm guessing it's written all the data again. Oh, yeah. We've written all the data again. Okay, so let's think. Let's go ahead and delete the file again. If price previous is less than price, then we do this. Oh, and we also need to tell it at the end, price previous is equal to price. Right, was that the issue? Because obviously we need to do this recursively. Yay, I think that was the issue. We're at 10 kilobit now. Let's have a look. Yep, that worked perfectly. We have all our sell orders. Sorry, I'm lagging quite a bit. Okay, perfect. So that was my 25-minute or so, 26-minute video on how to parse data. So let me know if I should make some more difficult videos although they would be relatively long. So I hope you enjoyed this, and I'm not too great at explaining, so there's probably a lot that is confusing, and this code might be quite messy, but this is how I would do it if I had only 25 minutes and I was being recorded while doing it. So I hope you learned something, and thanks for watching.